Now we are going to talk about LoRaS. LoRa stands for Low Rank Adaptation. In simple terms, a LoRa is a small add-on that modifies how a base model behaves. A LoRa does not replace the model. It works together with the model. You can think of the base model as the main photographer we hired earlier. A LoRa is like giving that photographer extra experience in a specific style or subject. Why LoRaS exist? Training a full model is very expensive. It requires a lot of images, time, and powerful hardware. LoRaS exists to solve this problem. Instead of retraining a full model, we train a small adapter that teaches the model something new. This could be a specific art style, a character, a face, a pose style, or a lighting style. LoRaS are much smaller than full models. That is why they are easy to download and experiment with. So remember, a LoRa does not work by itself. It always needs a base model and a compatible architecture. For example, a Stable Diffusion 1.5 LoRa needs a Stable Diffusion 1.5 model. An SDXL LoRa needs an SDXL model, and so on. If you mix incompatible models and LoRaS, the results will be broken or random. Let's open Comfy UI to test it, because what is theory without practice, right? Open Workflow 3, the one that has LoRa in the name. As you can see, the workflow is very similar to what we had before. That is one of the reasons I am using this older model instead of a newer one. It is easier to learn the basics first, and then we can make things more complex as we move forward. Compared to the first text-to-image workflow we used earlier, we now have this LoRa loader node that loads a LoRa model. In our photographer analogy, this means the photographer took some classes on how to take photos of cakes and is now specialized in that subject. Let's look at the note node first. We need to download the LoRa model. Remember, the workflow comes with nodes and settings, but since it is just a text file, it cannot include the actual models. We have to download those separately and place them in the correct folder. In this case, we are using a LoRa called Cake Style. It is a small model trained on images of cakes, so it understands cakes better than the base model alone. A few years ago, when Stable Diffusion 1.5 models first appeared, they could not handle many subjects very well, and LoRaS were often used to fix those limitations. So we need to download this LoRa and place it inside the LoRaS folder. Click where it says Here. Then we need to place that file in the LoRaS folder. Go to your Comfy UI folder, open the Models folder, and then find the LoRaS folder. If we place it directly here, it will work perfectly. But this time, I want to keep things organized. I want to create a folder that tells me which base model this LoRa is compatible with, so I will create a folder called SD15. This way I know it works with that model and I do not mix it with others. Save the LoRa inside that folder. If you look at the file now, you can see that the LoRa is much smaller than the base model. All LoRa's should go into this folder, and it is best to organize them by base model name, like SDXL, Flux, Qwen, and so on, just like we did with checkpoints in an earlier chapter. Now go back to Comfy UI. We have everything we need to run this workflow, but because Comfy UI was already open when we downloaded the model, it cannot see it yet. We need to press the R key to refresh the node definitions. Now it appears in the list and we can select it. You can also see a note here with a trigger word. I like to add these notes so I remember them. Many LoRa's are trained using specific trigger words. These are words the LoRa learned during training. If you do not include the trigger word in the prompt, the LoRa may have little or no effect. Some LoRa's work without trigger words, but many require them. Always read the LoRa description from the place where you downloaded it. If we look at the positive prompt, we first added the trigger words, so we do not forget them. It is not required to be first. It can also be placed after a few words, but I like to put it first. Then we have the prompt for a robot. I did it this way so we can clearly see how the LoRa and a simple trigger word affect the result. Now if we run this workflow, we get this robot cake. You might think this model could do that without a LoRa, but it depends on the prompt and the model. Let me change the seed to fixed so we can get a consistent result. So this is how it looks with the LoRa applied. Now what I want to do is see the effect the workflow without LoRa and without changing anything else. Same prompt, same settings, same seed, just disable the LoRa. To do that, I right-click on this node and choose Bypass. Now when I run the workflow, the LoRa is bypassed, and you can see we get a normal robot instead of a cake robot. If I enable the node again and run it, you can clearly see the effect the LoRa has on the image. Now that you see how it works, let's adapt a normal text to image workflow and add the LoRa ourselves for practice. Open Workflow 1, the basic text to image workflow. Now I want to add the LoRa between the model and the K-sampler. Double-click on the canvas, search for LoRa, and add the node called LoRa Loader Model Only. Let me resize it so the text is easier to see. I also like to color these nodes blue so I can spot them faster in big workflows, but that is optional. Now we need the model connection to go through this node. If you look now, the model is connected directly to the K-sampler, but we want the extra knowledge from the LoRa. Drag a connection from the model output to the LoRa loader, and then from the LoRa loader to the K-sampler. The workflow is now complete. Let's set the seed to fixed so we can clearly see how different settings affect the result. It runs without errors, so everything is connected correctly. Even if a LoRa sometimes works without a trigger word, it is best to include it when one is provided. So let's add the trigger word cake style to the positive prompt. Now when I run it, we get a different result even though the seed is fixed. That shows the LoRa is doing its job. If I change the seed, we get another variation. To avoid forgetting trigger words, I like to add a note node. I write the trigger word there, change the note title so it is clear what it is for, and often change the color to match the LoRa nodes so I know they are related. One important thing I have not mentioned yet is that you can use multiple LoRas. If I want, I can clone this node by holding Alt and dragging, then connect them one after another. You can stack several LoRas this way. I personally do not use more than 3 or 4 at once. In this setup, the base model is combined with the first LoRa, then the second LoRa, and all that information goes into the K-sampler. In the prompt, you add the trigger words for all the LoRas you use. If I run this now, some strange things can happen. First, I use the same LoRa twice, which makes its effect too strong. Second, when using multiple LoRas, it is usually a good idea to reduce their strength so they blend better instead of overpowering the image. If I lower the strength values, the result becomes much more stable and usable. If your result looks too weird, one of the first things to try is reducing the LoRa strength. Let me delete the extra LoRa and keep only one, then set its strength to 1. Each LoRa has a strength value. This controls how strongly the LoRa affects the model. Low values give subtle influence. High values give strong influence. If the value is too high, images can break, faces can deform, and styles can become unstable. A good starting range is usually between 0.6 and 1.0. There is no universal best value. Each LoRa behaves differently. Let's delete this LoRa loader node, and let me show you another node you can use, this time from a custom node. Search for Power LoRa Loader. This one comes from the RG3 node pack. What is different compared to the previous one is that it has 2 inputs and 2 outputs. Because of that, we need to route both the model and the clip through this node. First, connect the model output to the Power LoRa Loader model input. Then, connect the clip output to the clip input on this node. After that, the clip output from the Power LoRa Loader goes to both the positive and negative prompt nodes. Let me select all these nodes and move them a bit so you can see more clearly how both the model and the clip go through the LoRa loader. Now we can add the LoRa we want directly inside this node. We can also add multiple LoRas here. You can see that I can add a second one and even a third one. If I right-click on a LoRa entry, I can remove it. I can do the same for any of them. If we right-click on a LoRa and choose Show Info, we get more details. There is also a button called Fetch from Civit AI. Civit AI is a website that hosts models, and you will see it later. If the LoRa is public and available on Civit AI, this will fetch useful information about it, including examples and trigger words. We also have toggle buttons here. We can toggle all LoRas on or off, or toggle them individually. Let me add another LoRa so you can see how that works. This way, We can load multiple LoRa's, but enable only the ones we want at any moment. After playing a bit with this LoRa, I found that a strength value around 0.55 to 0.6 works better for this specific one. I tried it with the trigger word, then added an orange golden fish, cute and adorable, and got this result. It is not bad for such a small model. For a second example, I tried a marzipan cake shaped like a woman and got this result. For a third one, I tested a marzipan castle. Again, this is just for practice. Later, you will see better models that can produce much higher quality images with fewer errors. LoRa's are lightweight. They do not increase VRAM usage very much. Common beginner mistakes are using the wrong base model, using strength values that are too high, forgetting trigger words, and expecting a LoRa to fully replace a model. LoRa's enhance models. They do not replace them. Stacking many LoRa's can slow things down slightly, but not dramatically. For beginners, it is best to start with one LoRa at a time. The base model is the photographer. The LoRa is a specialty training course that photographer took. The photographer still uses the same camera. They just learned a new style. Now that you understand diffusion, prompts, image-to-image, LoRa's, and workflows, we are ready to talk about ControlNet. ControlNet is one of the most powerful features you can use in Comfy UI. In simple terms, ControlNet lets you guide image generation using an extra image, not just text. Instead of saying what you want only with words, you can also show the model what you want. What ControlNet is. ControlNet is an additional neural network that works alongside the main diffusion model. It does not replace the model. It does not replace the prompt. It adds extra control. The base model still does the image generation. The prompt still guides the style and subject. ControlNet adds structure and constraints. You can think of it like this. The prompt says what the image should look like. The seed decides the starting noise. The sampler and scheduler decide how noise is removed. ControlNet tells the model where things should go. Why ControlNet exists. Text prompts are powerful, but they are also vague. If you say a person standing, the model decides the pose. If you say a city street, the model decides the layout. If you say a face, the model decides the proportions. ControlNet exists for cases where you want more control. For example, you want a specific pose. You want a specific composition. You want to follow a sketch. You want to preserve the structure of an input image. ControlNet makes results more predictable and repeatable. This is a simplified explanation. In reality, ControlNet works by injecting additional conditioning into the diffusion process at every denoising step. But you do not need to understand the math. For learning and practical use, this mental model is enough. ControlNet guides structure while diffusion fills in details. Let's open Comfy UI, go to Workflows, and select workflow number 4, the one that has ControlNet in the name. The workflow is similar to the text-to-image workflow. It is still a text-to-image workflow, but it is guided by an image using ControlNet. You can quickly tell it is text-to-image because of the empty latent image node. I highlighted in yellow the nodes that we usually use for ControlNet. Let's go to the Note node to see what we need. The checkpoint model was already downloaded earlier. We also need to download some ControlNet models. For custom nodes, we need this specific custom node, which comes with the Easy Install version. But if you are using a different Comfy UI version, you need to install this node first. We have a Canny model, another one called Depth, and another one called OpenPose. There are more types available, but these are the most popular and commonly used ones. Let's download all three so we can test them. First, download the Canny model. Then go to your Comfy UI folder. Open the Models folder and think about where this model should go. If you guess the ControlNet folder, you are right. We place it there. Because different base models can have different ControlNet models, just like with LoRa's, a ControlNet is only compatible with the base model it was trained for. So let's organize them properly and create a folder so we know which base model these ControlNets are compatible with. Save the model in that folder. Next, download the Depth model and save it in the same folder. Then download the OpenPose model and save it in the same folder as well. Wait for all downloads to finish. If Comfy UI was open while downloading, we need to refresh it. Press the R key to refresh the node definitions. Now we have everything we need to run this workflow. In the workflow, we have an Apply ControlNet node with some settings. We also have a node that loads the ControlNet model we downloaded, and a preprocessor node that converts the input image into a format that ControlNet understands and was trained on. Let's run the workflow. In this example, we are using the Canny model. We loaded a bunny sketch, and with the help of the preprocessor, it generates a Canny map, which is an image that detects the edges of the input image. With the prompt, we influence what we want to generate, and with Apply ControlNet, the model interprets that Canny map and uses it to guide the generation to get this image. You can imagine that without ControlNet, it would be very hard to get something this complex using only a prompt, especially with the small model we are using today. Now let's build this workflow ourselves so you understand it better. Open again the first workflow that you already know how to build, and we will adapt it to use ControlNet. We know ControlNet comes before the K-sampler, so let's move some nodes to make room for it. Double-click on the canvas and search for Apply ControlNet. Add the node and change its color to yellow so it is easy to recognize. Now let's connect the parts that are obvious first. Positive goes to positive, negative goes to negative. For the outputs, there is only one place where they make sense, so we connect those as well. At this point, the node still has missing inputs. One of them is the VAE. We already know where the VAE comes from. In our case, it is included in the checkpoint model, the same VAE we already used for encode and decode. The next missing input is the ControlNet model itself. Double-click on the canvas, search for Load ControlNet, add the node, and color it yellow as well. Now connect it to the Apply ControlNet node. The last missing input is the image. Add a Load Image node. Then we can select an image. In this case, I will use a bunny sketch. You might be tempted to connect this image directly to ControlNet, but that usually does not work. ControlNet expects a very specific type of image because it was trained on that type of data. Our sketch is just a normal image, so we need a preprocessor to convert it into something ControlNet understands. Double-click on the canvas and search for AIO, which stands for All-in-One. Add the preprocessor node and color it yellow. Connect the Load Image node to the preprocessor, then connect the preprocessor to the Apply ControlNet node. Right now, the preprocessor is set to none, so we need to choose one. Since we plan to use a Canny ControlNet model, select a Canny Edge preprocessor. To better understand what is happening, add a Preview Image node after the preprocessor. This allows us to see the control image that is actually being sent to ControlNet. When we run the workflow, we get a Canny map, white edges on a black background. This shows exactly what ControlNet will use as guidance. You can also adjust the resolution here if you want more detail in the map. Now let's look at the result. It does not look very good yet. This happens often when working with ControlNet, and there are a few things to check. First, look at the prompt. We are still using a robot prompt, but the image is a bunny. So let's change the prompt to something like a watercolor painting of a bunny. Next, reduce the ControlNet strength and the N% slightly. Run again. The result is a bit better, but it still does not follow the sketch very well. If changing the seed does not help, the next thing to check is the ControlNet model itself. If you look at the Load ControlNet node, you may notice that the selected model is not a Canny model, but a depth model. That is the problem. The preprocessor and the ControlNet model must match. Select the correct Canny ControlNet model. Now run the workflow again. The result is much better and follows the sketch closely. Let's try another example. Load a 3D text image. Since this image has depth information, we can try a depth ControlNet instead. Change the ControlNet model to depth and update the prompt to something like golden text in snow. When you run it, you may notice the preview still looks like a Canny map. That means we forgot to change the preprocessor. Switch the preprocessor to a depth preprocessor. The first time you run a new preprocessor, Comfy UI may take longer because it downloads a small model automatically. This only happens once. If you get a long path error on Windows, close Comfy UI and run the long path enabler from the Tools folder. Now we see a depth map. Dark areas represent parts that are farther away, lighter areas represent parts that are closer. ControlNet uses this information to understand spatial structure. The generated result now follows the depth and composition of the original image very closely. If for some reason you get an error saying the model is incomplete or something similar, you can close Comfy UI, go to the Tools folder, and run the batch file called Long Path Enabler. This should fix the long path issue and allow Comfy UI to download the model it needs, even when the file path is longer. You can also try the same image with a Canny ControlNet, switch both the model and the preprocessor back to Canny and run again. Even if some edges are missing, it can still guide the generation well. Try switching back to depth and compare results. Often one will work better than the other depending on the image. Now let's talk about the key ControlNet parameters. ControlNet does not replace diffusion. It only guides it during certain parts of denoising. Strength controls how strongly ControlNet influences the image. Low values make ControlNet a soft suggestion, and the model can drift away. High values strongly enforce structure and make the output closely follow the control image. Typical values are between 0.5 and 0.7 for natural results, and 0.8 to 1 for strict structure matching. Start percent controls when ControlNet begins influencing the denoising process. A value of 0 means ControlNet starts from the very first step, locking structure early. Higher values allow the model to form rough shapes first before ControlNet takes over. End percent controls when ControlNet stops influencing denoising. A value of 1 means ControlNet stays active until the end, locking structure even in fine details. Lower values allow ControlNet to stop earlier, letting the model finish on its own and add more style. In simple terms, strength is how hard ControlNet pulls. Start percent is when it starts pulling, and end percent is when it lets go. That is why ControlNet is so powerful. You can guide structure without killing creativity. It is time to test the pose ControlNet as well, but first let us add a pose image as reference. Let us say I add this woman. Again, it is kind of hard to put into words the exact same pose, so this is a good use case for ControlNet. Let us change the prompt to something else, maybe woman in a sumo yoga pose, not sure how to call it. Then do not forget to change the model to open pose. I know it might seem complex at first, but newer models have Union Control Net models that include everything in one, so you only load one model, which makes things easier. That said, this is how we used to do it, and there are still cases where we need specific models. Then we can try either DW pose or open pose. Type pose and select this open pose, and then let us run it. Again, it will take a bit since this is the first time I use it. In fact, if you look at the command window, you can see it is downloading that model from Hugging Face. That is why it takes so long. After it finishes, it gives this pose image that looks like a skeleton, with each color representing a bone. That is how it knows which side is right and left and so on. So it captured the pose, and now let us see the result. Holy sumo, what is this? Okay, let us adjust the prompt. Maybe a fit woman will help. That did not help much. I bet the word sumo has too much weight. Like we talked about before, some words have more power than others. So if I try without that word, I get a better result. Even the face is not so great, and that can happen with people in the distance. Usually with portraits, we get better faces. Newer models fixed most of that. Let me try to change the resolution to see if something changes. Now I get a better resolution for the skeleton, and the pose is okay, just the face. That face does not invite me to do yoga. Okay, let us try a different pose, something for a portrait. Let us say I use this portrait photo. Let us change the prompt to a businesswoman and run it to see what we get. The pose looks okay, even if it is missing an arm, it should still work. The results are much better now that the face is closer. Let us try a warrior woman as well. That works well too. So with ControlNet, you have to continuously search for balance. Make sure you select the right ControlNet model for the job. Then choose a preprocessor that matches the model. As you saw, it is easy to forget to change something. I usually play with strength and end step. Also, do not forget, ControlNet models made for SD 1.5 only work with SD 1.5 base models. If you use SDXL, you need SDXL ControlNet models. In a later episode, we will check some advanced models that do not even need ControlNet and can do everything from prompts. Beginner mistakes to avoid. Using the wrong ControlNet model for the base model. Forgetting to install or download ControlNet models. Using very high strength values. Expecting ControlNet to fix bad prompts. Using ControlNet when it is not needed. ControlNet is a tool, not a magic fix. When you start using Comfy UI, you will notice there are many different model types. AIO models FP16, FP8, GGUF, and others. This can be confusing at first, but the reason is actually simple. At their core, all diffusion models are just very large collections of numbers. Those numbers represent what the model has learned. The knowledge itself does not change, but the way those numbers are stored can change. Different model formats exist to balance memory usage, speed, and hardware compatibility. Some formats are larger but more precise. Others are smaller and faster but slightly less accurate. FP32 is the highest precision and is mostly used for training. It uses a lot of memory and is rarely used for image generation. FP16 is the most common format for stable diffusion. It offers a very good balance between image quality and VRAM usage. This is the safest and most recommended choice for most users. FP8 uses even less memory and can be faster on newer GPUs that support it. The trade-off is that it can sometimes reduce image stability or detail slightly. AIO models stand for all-in-one. They bundle the main model, VAE, and sometimes clip into a single file. They are designed to be easy to use and reduce setup mistakes. The downside is that they give you less flexibility if you want to swap components later. GGUF models come from the language model world. GGUF stands for GPT Generated Unified Format. They are optimized for very low memory usage and can run on CPU or low VRAM systems. It is important to understand that these formats do not make the model smarter or more creative. They do not change what the model knows. They only change how efficiently that knowledge is stored and processed. You can think of it like the same video saved in different resolutions. The content is the same, but the file size and playback requirements are different. For most users, FP16 models are the best starting point. AIO models are great for beginners. FP8 is useful if your GPU supports it. GGUF is best when memory is very limited. Once you understand this, choosing models becomes much easier. You saw in the workflows that I include links to models, but you might wonder where I find those models, right? One of the sites is Hugging Face, but it is not the most beginner-friendly one. At the top, we have a Models tab, and here you can find a lot of models, but not all of them are diffusion models or used for generating images. Some are for video, some for audio, some for large language models, and many are not compatible with Comfy UI. Some require different interfaces to run, or they are so large that you cannot even run them on your computer. For example, I can sort them by text to image, and here you can see some popular ones like Qwen, ZImage, or even the Flux model. If I click on one of these, you will see that some models require you to sign in and accept certain terms. Each model has a license. Some are open source, some are free with conditions, and others are available only in certain countries. By default, you are on the model card. This is basically an info page about the model. On another tab, you have Files and Versions, where the files are usually available in different formats. Like in this example, and there are a few more files inside those folders. Let us go back to the home page. Here you can also search for a model if you know the name, or browse popular ones, like ZImage. Always check the tabs at the top to find more information about the models, since they can be quite large and you want to make sure you can actually run them on your system. I know this is a lot of information, but as I said before, I usually include the model link directly in the workflow, so you do not have to stress about it. Still, it is good to understand how models work and where they come from. Another site that is more beginner-friendly and better organized is the Civit AI website. The downside is that recently they removed access for some countries, like the UK. If you are from one of those countries, you will need a VPN to access it and download models. If you click on the Models tab, you can find all kinds of models for different interfaces like Comfy UI, Forge UI, and others. Most of them are compatible with Comfy UI. On the right side, you have filters. These let you sort models by when they were added. You can also filter by model type. For example, checkpoints are the main AI models. You can also filter by LoRa or ControlNet, since we talked about those model types in previous chapters. Of course, you can also filter by base model, so you know what is compatible with your workflow. The first workflow we used was based on an SD 1.5 model, but I can also sort by other ones, like the FluxDev model, or an older one like SDXL. By the way, SDXL is newer than SD 1.5, and Flux is even newer than SDXL. So use these buttons to sort models. If you already know the name, you can just search for it. For example, I can search for Juggernaut. Here you can see multiple versions of that model based on different base models like SDXL or SD1. If I click on SD 1.5, I will only see those versions. If I click on the one that says Juggernaut, it opens the model info page. At the top, you can see different versions. We used the Reborn version, but you can try other versions as well. Below that, you have details about the model. It clearly says what type it is. It can be a checkpoint, a LoRa, or a checkpoint merge. In this case, it is a checkpoint merge, which means the main SD 1.5 model was mixed with other SD 1.5 models to combine the best parts of each one. It also clearly states that this is a base SD 1.5 model. You can see the publish date as well, which shows that it is quite old. At the top, you have the download button, and the file will go into the correct folder. In this case, it goes into the checkpoints folder. As I mentioned before, the author sometimes includes recommended settings. You can see them here. This is how I knew what settings to use in the K-sampler for the workflow. At the top, you also have a gallery with images generated using that model. This helps you understand what the model is capable of. Some images also have an info button that shows the prompt and settings used to generate that image. So, explore Civit AI if you have access to it, and see what models and LoRa's are available. Once you are signed in, you also get more options to control what type of models are visible, since some are disabled by default. So now that we played a little with that old SD 1.5 Juggernaut model, it is time to try a better, newer model to see how far AI has come in just 2 years. Let us go to Workflows again, and this time open the workflow named 5A, the one for Z Image Turbo with the all-in-one model. The workflow is quite similar to the others we tried. We just have 2 extra nodes this time. One of them is this conditioning node that we use instead of the one for the negative prompt, and the other one is this model sampling node. Since we are using a new model, we need to download it because we do not have it yet. The model is called Z Image Turbo. Juggernaut and Z Image Turbo are very different types of models, built with different goals in mind. Juggernaut is based on Stable Diffusion 1.5. It uses the classic diffusion architecture that has been used for years. The model file itself is relatively small, usually around 2 GB. Juggernaut was created by the community by fine-tuning and merging Stable Diffusion models. Z Image Turbo is a newer type of model created by the Tongyi team from Alibaba. It uses a more modern architecture designed to generate images more efficiently. Even though Z Image Turbo is much larger in file size, it is optimized to produce good results in very few steps. One important difference is how the models understand prompts. Juggernaut relies on the classic clip text encoder. It understands prompts if are short, but it often requires careful wording, sometimes keywords like prompts. Z Image Turbo uses a more advanced text understanding system inspired by large language models. This allows it to understand prompts in a more semantic and natural way. Because of this, Z Image Turbo can often follow instructions better, even with shorter or more loosely written prompts. So in simple terms, Juggernaut is smaller, very flexible, and highly compatible. Z Image Turbo is a larger, newer model and smarter at understanding what you ask for. So we have here an all-in-one model. And there are two types, a smaller one FP8 and a bigger one BF16. It depends on your graphic card. If you can run the big one, use that one. For this first episode, I want to run it on a low VRAM card, so I will use the FP8 small version. All-in-one means it has everything it needs included. The clip and VAE model in this case, so we do not need to download those models separately. That is why it is easy to use for beginners. The models go into the checkpoints folder, and there we can create a special folder for the Z image model. Also, if you want to learn more about the model, I included an info link here, so click on it. Now we are on the Hugging Face page, and you can learn more about this specific version, from workflows to different model versions. If we go to Files, we can see different model versions that you can try depending on how good your graphic card is. So let us test the small version. Click here, then go to Comfy UI, go to Models, then Checkpoints, and create a folder called Z Image so everything is more organized. Inside this folder, place the model. Since this is a big model, you need to wait for it to finish downloading. Because Comfy UI was open, you can see that it does not appear in the list yet, only Juggernaut. So I press the R key to refresh node definitions, and now we can see both models, nicely organized in folders. First is Juggernaut, and second is Z Image. So let us select the Z Image model. That is all for the model download, and now we can run the workflow. The first time you run a workflow, it is slower because it needs to load the model. The second time you run it, it should be faster. For me, it took about 10 seconds because I have a lot of ROM and VROM. The result looks pretty good compared to the robots we used to get with the SD 1.5 model. We have much nicer details. For the image size, I used a smaller size so it runs faster. This model was trained with bigger images, not like SD 1.5, so we can even use larger sizes like 1600 pixels if we want. Even if you go bigger than the size it was trained on, it does not produce many errors like SD 1.5 did. It just becomes a bit more diffused. Usually, for most newer models, a good place to start is around 1024 pixels. So let us say I try a landscape image this time, using these sizes. The result looks pretty good. I like it. Let us go back to workflows again and open the first workflow to see what is different and how we can recreate the Z Image Turbo workflow. So we already have the right node to load the model in this case, so I just select the model from the list. For empty latent, this one is used more for older models with a different architecture. Many newer models use a different empty latent node. If we look at the nodes and search for empty, we have one empty latent and one empty SD3 latent. In this case, we want the one with SD3. On the surface, they look identical. It is just a different latent representation internally. If we make it purple, it looks like the previous one. If you do not have enough VRAM to run this, you can use sizes like 768 for width and height. I will use 1024 pixels since it is the most popular size and my system can handle it. So let us delete the old empty latent and now reconnect the new node. This model does not use a negative prompt, only a positive one, so I will remove the negative text. You can also collapse it if you want, that way you know not to add a negative prompt. Then we have the settings, which, as you remember, are different from model to model. If we look here, we only have 5 steps, so it can generate with fewer steps, and the CFG is 1. Let us change the steps to 5, and the CFG to 1. When the CFG is 1, it ignores the negative prompt. We also need a sampler and a scheduler. So let us add the DPM++ SDE sampler, and for the scheduler we use beta. Let us see what else is missing. We have this extra node called Model Sampling Auraflow. It has a long name, not sure why it cannot be something simpler, but anyway, let us search for that node. We change the shift to 3, and we make the connection go through that node, just like we did with LoRa. The Model Sampling Auraflow node is a special node that modifies the model sampling behavior before it goes into the K-sampler. It is designed to work with models that use the Auraflow sampling method, which is an advanced sampling technique used by some modern models for better stability and quality. What this node does is apply a sampling adjustment or patch to the model itself, so the sampler works in the best way for that model. The node takes the current model and a shift value as inputs, and outputs a modified version of the model with the Aura flow sampling logic applied. The shift parameter controls how strong that sampling adjustment is. Changing the shift value can subtly affect contrast, sharpness, and how the generation behaves internally. So we changed the empty latent to the SD3 version. We added a node to shift the model values, and we adjusted the settings to work better with the Z-image model that we loaded in our workflow. Let us run it and see if it works. As you can see, it works just fine, and we get a nice robot. If we look at the previous Z-image workflow, you can see that it does not use a negative prompt, but instead it has a conditioning 0 out node. So let us go back to our workflow and search for that conditioning node. As I mentioned before, this model does not use a negative prompt, so you might wonder why we do not just delete the node. We could do that, but then we would have a missing input, and the workflow would throw an error. To fix this, we use the conditioning 0 out node. You can make space for it and place it between nodes if you want. This conditioning does not come from clip like the negative prompt did before. We connect it directly to the negative input on the K sampler. You can place it wherever you want to make the connections clearer, but I like to put it under the positive conditioning to save space. The conditioning 0 out node does exactly what its name suggests. It removes the influence of a conditioning input without breaking the workflow. In simple terms, it takes a conditioning signal, usually text conditioning, and replaces it with a neutral, zeroed version. So the model still runs normally, but that conditioning contributes nothing to the generation. Why this exists, and when it is used. In diffusion models, the sampler always expects both positive and negative conditioning inputs. If you want to remove or disable one side, you cannot just unplug it. That would break the workflow. Conditioning 0 out is a safe way to say, use conditioning, but make it have no effect. So if we run the workflow, everything works fine without any errors. Now, the good part about Z-Image Turbo is that it is very good at realistic images, but it is also very good at understanding prompts. For example, if I want to create a portrait of a cat with a hat, I can easily get an image like this. But you can also create more complex prompts by using a large language model. Maybe you use ChatGPT, Gemini, or even a local LLM. I will use ChatGPT for this example. I ask it for a detailed photo prompt and give it the details of what I want. ChatGPT then gives me a long, detailed prompt that I can copy and paste directly into Comfy UI. So let us test it again. Now we get a different cat, but it is still a bit too simple. Let us make it more complex. I go back to ChatGPT and ask for the cat to hold a rose in her mouth and wear a t-shirt that says Pixa. Again, we get a long detailed prompt, and from that prompt we get this image. Sometimes the model can take things very literally, so you need to explain details clearly if you want more control. For example, you might need to mention that you want a full rose held horizontally in the mouth, and not something else. Let us create something different now. This time, a cartoon bunny, since this series is full of bunnies anyway. Again, we get a nice prompt, and the result looks like this. It is pretty cute. Maybe now I want the bunny to be a ninja. Let us see what this prompt generates. And we get our ninja bunny. If we generate again, we get another one. As you can see, compared to older models, the results with different seeds are quite similar. You do not get a huge variation from seed to seed. That is why I recommend using longer prompts and adjusting each prompt carefully. This model is very good at following instructions, so the more precise you are, the more control you get over the result. Let us open the first workflow again so we can compare it with workflow 5a. Now let us say I use the same long prompt and the same fixed seed for both workflows. If I generate with Z-image, I get a robot like this one, which looks nice and detailed. Now if we try the old Juggernaut model using the same prompt and the same fixed seed, the result looks like this. It is smaller and much less detailed. Let us copy this image and paste it into this workflow so you can clearly see the difference in quality and also how well Z-image follows the prompt. But maybe this single test is not enough to fully see the difference, so let us try something else. Let us test text generation. Newer models can generate readable text, but older models usually cannot. We normally put the text we want inside quotes, so let us test that. Look at this result. It looks very good, and it understood the assignment. Now let us go back to the Juggernaut model and use the same prompt. We get something like this. What is this? What does it even say? Gold Gola or something like that. It clearly cannot do text. Let us go back to ZImage and try another test. A red sphere on top of a green cube placed on a black car. We get this realistic result. ZImage is more specialized in realism, but it can also do 3D, paintings, and other styles. Now let us see what Juggernaut does with the same prompt. It gets the red sphere since that was mentioned first, and then it gets lost and forgets what it needs to do next. So clearly, ZImage is a very good model to have, and you will probably spend more time playing with this model. Still, keep an eye on new models because they keep getting smarter and better as they get more training. You have now seen how an all-in-one model works and how we load checkpoints. In the next chapter, we will use models that are split, where Clip and VAE are loaded separately so we can have more control. Let us talk a little bit more about diffusion models. Open Comfy UI and then open Workflow 5a and also Workflow 5b so we can compare them. In the first workflow, ZImage is loaded as an AIO model. AIO means all-in-one. You can see that we used a load checkpoint node to load that model. The checkpoint already contains the diffusion model, the text encoder, the VAE. Everything is bundled into a single file. Advantages: very easy to use, fewer nodes, less setup required. Good for quick testing and simple workflows. Disadvantages: less flexible, you cannot swap the text encoder, you cannot change the VAE, harder to customize or optimize. This format is designed for simplicity and convenience. Now let us check the second workflow, the 5b version. You can see that we have 3 nodes now instead of 1. We have the load diffusion model node that loads the main model. Then we have the clip load node that loads the text encoder. And then we have the load VAE node that loads the VAE. So it is like we split the previous checkpoint into separate pieces, and now we have more flexibility. Even though the final result is still ZImage Turbo, the pipeline is modular. Advantages: more control. You can change the text encoder and experiment with different VAEs. Better for advanced workflows and optimization, and easier to update individual components. Disadvantages: more complex setup, more nodes, higher chance of misconfiguration if you do not fully understand what each part does. However, this is actually one of my favorite workflows. The reason is flexibility and efficiency. With a modular setup like this, you save disk space. For example, this VAE is the same VAE used by the Flux model, so if I already use Flux, I do not need to download the VAE again. With an all-in-one model, every new version means downloading the entire model again, even if only one part changed. In a modular setup, I can update or swap individual components. I can test different text encoders without downloading the main diffusion model again. So while modular workflows require more understanding, they are more efficient, more flexible, and better for experimentation. That is why I personally prefer this approach. But we did not download these models yet. I suggest that when you follow this tutorial, you test everything to see what is better or faster on your computer, and then keep only the ones you like. There is no point in keeping all types of models if they do the same thing, unless you have a lot of space on your hard disk. So let us start with the main diffusion model. This long name is actually describing how the model is built and optimized. ZImage Turbo. This is the model family and architecture. FP8. This means the model uses 8 bits floating point precision. FP8 models use much less memory than FP16. I did not include a link in this tutorial for the FP16 version, but you can find those online if you have more VRAM and want to try them. Scaled refers to the FP8 format being calibrated for better precision. This improves quality and stability compared to a raw, unscaled FP8 format. You can think of it as FP8 with tuning for better accuracy. E5M2. This is the specific FP8 encoding variant used. KJ. It is usually a variant tag or builder ID added by the person or team that exported or repackaged the model. It does not change the model itself, it just helps distinguish between different builds. Safe tensors. This is the file format. Safe tensors is a safe and efficient format and is recommended over older formats like CKPT for better stability and speed. We can download this model from here, and I also added more info about the model so you can check different versions. You can also see the author, so now you know what that KJ in the model name stands for. So let us click here and see where we place it. Navigate to the Comfy UI Models folder. You should already know this by now. This time we do not use the checkpoints folder, because that is usually for complete models that already include most of what they need. Instead, we place this one in the Diffusion Models folder. To keep things organized, we create a folder called ZImage and place the model inside. Next, we have the text encoder. I used one recommended by ASD from the Discord server, but there are other text encoders you can try, made by different people. For this one, we again go to the Models folder, and this time we place it in the Text Encoders folder. Here, I do not create a ZImage subfolder, because many text encoders work with multiple models. I usually create subfolders only for main models, LoRa, and ControlNet, when it is important for the workflow that they match the same base model. Then we have the VAE. This is the same VAE that we might also use later for the Flux model. So again, we go to the Models folder, and this time we place it in the VAE folder. Some of these models are large, so wait for them to finish downloading. Once everything is done, press the R key to refresh the node definitions. Now let us check that all models are visible and selected correctly. The ZImage diffusion model is here, the clip text encoder is here, and the VAE is also here. That means we have everything we need to run this workflow. So let us click Run and see if we get any errors. Everything works fine and we get this image. What I usually do next is compare the results with the first workflow. When I have multiple models available, I download all of them, test them, keep the ones I like the most, and delete the rest. When I do testing, it can get confusing which model generated which image, so here's a small trick. Double-click on the canvas, search for iTools Add, and select the node called iTools Add Text Overlay. This node comes with Easy Installer, but if you have a different Comfy UI version, you can install the iTools nodes from the manager. We add this node right after VAE decode and before the Save Image node. This way, the final image goes through this node, the text overlay is added, and then the image is saved to disk. For example, we can add the model type in the text overlay. You can also add more text like the model name or other info. Let us say I add FP8 scaled diffusion, so I know this image comes from this workflow. Now when I run it, text will be added on top of the image. We can control the text, the background color, the font size, and whether the text overlays the image or is placed under it. Let us disable overlay mode and try again. Now the text is under the image. This way, we know exactly which model generated it. Next, I select this node and press Ctrl+C to copy it. Then I go to the first workflow and press Ctrl+V to paste it. Now we connect the node the same way as before. We need a name that represents this model, so let us name this one FP8 All-in-One. Now I can test it, and you can see the text under the image. To make a fair comparison, we use the same settings for both workflows. Let us also enable the bottom panel to see how much time it takes to generate. As you remember, the first time you run a model, it is slower because it loads the model. We can unload the models using this button and clear the cache using this one. This lets us compare which model loads faster and which one generates faster. I run it once, and you can see the first run took around 8 seconds. The second and third runs are faster, around 3.57 seconds. Now let us go to the second workflow. I unload the models and clear the cache, then run it again a few times. This one loads slower, but the second and third runs are faster. On my older PC, the all-in-one model was faster, so it really depends on your system. Test it yourself and see what works best for you. Now let us look at quality. We use a fixed seed with a value of 50 and run the workflow. Then we do the same for the first workflow, same fixed seed, and run it. Right-click on the image result and copy the image. Then create a new workflow where we compare the two images. I press Ctrl+V to paste the image, and you will see it adds a load image node with that pasted image. I do the same for the image from the second workflow. Now we have both results. Let us add an image comparer node so we can compare them. Connect the first image to image A and the second image to image B, then run the workflow. Now we can enlarge and compare them. The results are quite similar, but still slightly different. This happens because I used a text encoder that is different from the one included in the all-in-one workflow. If I had used the same text encoder, the results would have been much more similar. Let us try again with a different prompt. Maybe we do a portrait photo of an old woman. We get a result like this one. Now let us do the same for the second workflow, and we get another woman for this one. Let us copy both images and go to the comparer workflow. Select the Load Image node and use Ctrl+V to paste the image into that node. Now we can compare the two results. Again, because the text encoder is different, the comparison is a bit harder. Still, I kind of like the FP8 scaled version more. You can see that we use the same settings for both workflows. One has everything included, and the other has everything separated. If I searched for the same clip used in the AIO workflow, I could get much closer results. This load clip node is something we will use in other workflows as well. As you can see, it has a type option that lets you select different types of models to match the diffusion model you loaded. Do not stress too much if you do not understand everything yet. It will make more sense as you practice. If we look at the VAE, you can see where it goes. As you remember, we use it to connect to nodes like VAE decode and VAE encode. If we go back to the first workflow, that VAE is coming directly from the one included with the main model. Different model formats do not change what an AI knows, they only change how that knowledge is stored. So choosing the right format is about balancing quality, speed, memory, and flexibility for your hardware and workflow. GGUF stands for GPT Generated Unified Format, and it is a model format designed to run large models efficiently on systems with limited memory. In Comfy UI, let us go to Workflows again, and this time open Workflow 5B and 5C so we can compare them. The workflow we saw in the previous chapter had three nodes: Load Diffusion Model, Load Clip, and Load VAE. And you can see that it was loading SafeTensors files. If we go to the GGUF workflow, you can see that some nodes are different. We now have a UNet loader that has GGUF in the name, and the file format is GGUF instead of SafeTensors. We use this node to load GGUF type diffusion models. For the clip, we could have used the previous node to load an existing text encoder, but I wanted to show that you can also use a clip loader GGUF node to load text encoders in GGUF format. The last node is the same load VAE as before. So, compared to the previous workflow, we only changed two nodes so we can load GGUF models. But we do not have those models yet. So let us go to the notes and check which node loads which model, and also look at the download links. If we go here, you can see there are many GGUF model versions. Most of the time, you will see something with a Q version in the name, like Q2, Q4, Q6, or Q8. Most of the time I use Q8 models. If that is too big, I switch to Q6, and if that is still too big, I use Q4. The lower the Q number, the lower the quality of the generation, but the models are smaller and can be faster on limited hardware. Let us look at what this model name means. Z-Image Turbo. This is the core model family and variant name. Q4. This means the model is quantized to 4 bits precision. Lower bit quantization reduces file size and VRAM usage. The K indicates a specific quantization method, usually a block-based or K-quant method, which helps preserve model accuracy even at low bit precision. The S usually means small or standard variant within that quantization type. It trades a bit more quality for a smaller footprint compared to M versions, which stand for medium. GGUF. This is the file format. Let us download this model and give it a try. We go to the Comfy UI folder, then to the Models folder. This main model, just like in the previous workflow, goes into the Diffusion Models folder. Since we already have the Z image folder from the previous chapter, I will place it in the same folder because it is the same base model, just a different quantization. So we save it there. Now let us do the same for the text encoder. We click here to download it, then again go to the Models folder, find the Text Encoders folder, and place the model there. For the VAE, if you followed the previous chapters, you should already have it. If not, download it and place it in the VAE folder. These models are big, so wait for them to finish downloading. After the download is finished, press the R key to refresh node definitions, so Comfy UI can see the new models. Now we go back to the nodes and make sure we can select the models. The Z image model is there. The text encoder is also there. I am using the one with gguf in the name because if you use a SafeTensors version here, even if it does not give an error, the results will not be what you expect. For the VAE, we already have it. So now we have everything we need. Let us run the workflow. The result looks pretty good for a Q4 version. Let us open the bottom panel and run it again. You can see that the first time it loads the model, it is slower, but after that, it takes around 5 seconds to generate. In my case, this was slower than the all-in-one model or the FP8 scaled version. That does not mean it will be the same on your system. On some systems, it might be faster. That is why I keep saying you should test everything and then keep the best model for your setup. What is best for me will not necessarily be best for you, because we have different video cards, different VRAM amounts, and probably different drivers. Now I am curious how a larger Q version will perform. So let us go back to the model list. This time I want to test a bigger one. The biggest available here is Q8, which is around 7 GB in size. I have 24 GB of VRAM, so I can easily fit this model in memory, and even larger ones. Sometimes, if a model is larger than your available VRAM, it will be slower because it tries to load the model in parts. You lose time during that process, and generation can be slow or it can even crash Comfy UI and force you to restart it. So let us download this one. We place it in the Diffusion Models folder, inside the Z image folder, right next to the Q4 version. Again, wait for it to finish downloading. Luckily, I have a fast internet connection. After that, press R to refresh. So now, in the UNet loader, we can see both models. By the way, UNet is the main neural network inside a diffusion model that predicts what noise should be removed at each step to turn random noise into an image. First, let us change the seed to fixed so we can compare the models properly. I get this image for Q4. I copy the image, create a new workflow, and paste it there. I will rename the node to Q4 so I know which model was used. Now, let us go back to the workflow and select the Q8 model. Everything stays identical, only the model changes. Let us see what we get. It looks similar at first glance. I copy this image, go back to the new workflow, and paste it there as well. I rename this one to Q8. At first glance, the Q8 version seems to have fewer mistakes and looks clearer. Let us add an image comparer node to compare them properly. Connect the two load image nodes to the image comparer and run the workflow. The first image shown is image A, which is the Q4 version. As we move the cursor to the right, we see the Q8 version. In my opinion, Q8 has better details and fewer errors. For example, some bolts seem to be missing in the Q4 version, while the Q8 version looks more complete. In most cases, Q8 will be better than Q6 and better than Q4 in terms of quality. But now let us check the speed. The first time, Q8 took longer to load because it is a 7 GB model. Let us change the seed and try again. Now the second run takes under 4 seconds. Let us try once more. We change the seed again, and once more it takes under 4 seconds. Now let us switch back to the Q4 model. This one is lower quality, but also smaller. You can see that the first time it loads faster. Let us change the seed and try again. The second run takes more than 5 seconds. Let us try one more time, and again it takes more than 5 seconds. This is why I keep saying you should test all of them and then decide. For me, Q8 is faster and gives better quality than Q4, but that is because my video card probably works better with that quantization. On your system, especially if you have an older card, it might be the opposite, and Q4 could be faster. So please test them yourself, and then keep the one that gives you the best quality and the best speed on your system. So let's go to workflow again. And now it might make sense why I named Workflow 5 all these 3 workflows, because they are workflows for the same model, just different model types. So let's open Workflow 5a, and you will see how we can adapt the workflow. Let's move this to the side. So this has an all-in-one model with everything included. We want to change it into a workflow where the models are split. So let's start with the model. Instead of load checkpoint, we search for load diffusion model. This one only loads the model without clip and VAE. And we select the Z image model from the list. Then we need a node that has that clip output that loads the text encoder. So we search now for a node called load clip. Let's make it bigger so we can see the parameters. We first select the text encoder. Then we select the type. Z image uses Lumina 2. Lumina means light. You can think of it like reaching the end of a tunnel. Z is the last letter of the alphabet, and at the end, you see the light. Lumina 2 represents a newer, clearer way for the model to understand prompts and guide image generation. It simply means more advanced guidance compared to older models. Then what is left is the VAE, so we use the load VAE node, and we select that VAE model. So now all that's left to do is to redo the connections. We drag a link from model to model. Pretty easy, right? Now we need the clip, so let's drag another link. And all that's left is the VAE. This one will connect to the VAE decode node, and if the workflow is image to image, it will go to VAE encode also. Now we can get rid of the load checkpoint node. So now we successfully replaced all the models, and basically we have the workflow version 5b that we used before. So let's run it, and it all works okay as it should. Let's say the model we use now is too big and our video card doesn't have enough VRAM. Then we can try a GGUF model to see if it works faster or better. So let's search for a node again, and this time search for the UNet loader, the one that has GGUF in the name. So in this node we can select a GGUF model. You can see I downloaded 2 versions before. So let's say Q4 is smaller in size than the FP8 version in this case, so it has better chances to run faster than a bigger model. But as you saw before, on my computer, Q8 was faster, so maybe I will use that to get better quality instead. Let's connect the model, and now we can remove that node. So we replaced an FP8 SafeTensors model with a GGUF version. And if we run this workflow, you can see it works just fine, and we got a nice result. If for some reason you are not happy with the text encoder, maybe it is not so accurate or it is too big, we can try a GGUF version of the text encoder also. So let's delete that node and let's search for ClipLoader, the GGUF version. You can see it has ClipLoader in one word. So now we can select the GGUF model. And of course, we need to adapt the type since it is not Stable Diffusion, it is Lumina 2 instead. Remember that light at the end of the tunnel. And then link the clip to text encode prompt. And basically now we have the workflow 5c. So you saw that having a modular version allows you to change models and have more freedom, just like on your computer. If you are not happy with a mouse or your printer, you can change it with a smarter or faster version. Now, if you do have enough VRAM, you can try to increase the size for width and height to get more details. For example, at this size, I got this image, and now we can see more details on those cables and overall. But usually for Z image, I use values between 10, 24, and 1280 pixels. So at the moment of this recording, Z image is a pretty good model to have. It is free, and you can generate all kinds of stuff with it. Let's compare a few of these models to see what the difference is. So for this one, I compared the FP8 all-in-one version with the FP16 all-in-one version, which is double the size. The results are quite similar. Maybe the FP8 is a little more desaturated compared to FP16, and FP16 might be a little bit clearer, but it is not a huge difference. Both are good quality. For the Viking image, the FP8 version has fewer details in some areas. In FP16, it added some extra things, like more ornaments. Again, FP8 looks a little more desaturated. For the bunny, both look good. So I would say if FP8 is faster, has half the size, and the results are very close, you can get away with FP8 and keep that. Now let's compare the FP8 version with the FP8 scaled version. Keep in mind that the text encoder is also different in this case compared to the one included in the first model, but the results are still quite similar. Sometimes FP8 does it better, sometimes the scaled version does it better, so if you do more tests, you can decide which one is better for you. Since the results are very close, again, it makes sense to keep the one that is faster on your system. Now let's compare the FP8 version with the GGUF version. Instead of the Q4 version, I will use the Q8 version downloaded from here so we can see the difference. For the portrait, it looks a little clearer on the Q8 version. For the Viking, some details are more defined on the Q8 version. For the bunny, it is pretty similar for me. For other models we will test in the future, the difference might be bigger and more obvious, but in this case, the difference is quite subtle. So which one will I keep for my video card? Maybe the FP8 scaled or the Q8 version, mainly because they are modular and I can save space and time when I use the same models for other workflows. In this chapter, we explore batch generation and styles. So let's open another workflow, this time workflow 5A. Since it has fewer nodes and you can see things better, but the methods I show work with any workflow. Right now, each time you press the Run button, the workflow runs once and you get a single image. But what if you want more images and you do not want to click Run every time? In this node, we have an option for batch. By default, it is set to 1. You can change that, but keep in mind it will use more VRAM because it is like running multiple workflows at the same time. If your video card can handle it, it will be faster than generating one image at a time. So now we get 2 images. If I change it to 4 and run again, we get 4 images. If we toggle the bottom panel, we can see the time it took for 1 image, for 2 images, and for 4 images. If we multiply 3.77, which is the time for 1 generation, by 4, we get over 15 seconds. But because we used batch, it only took 13 seconds. So you need to see what batch size works best for your video card. I might be able to use a bigger batch, but you might need a smaller one. Now from these 4 images, we can click on any of them to open it bigger. These images are saved in the output folder as well. To close the big preview, you can use the X in the top right. Let's open another one. You can also navigate using the buttons in the bottom right corner, so you can check all generations. The bigger the image, the more VRAM it will need. Let's say I set the batch to 8, since the image size is quite small. The result is 8 images. You can check the results and pick your favorite. You can right-click on an image and save it in any folder you want. Now let's change the batch back to 1, so we only get 1 image. Next to Run, we have an arrow that shows multiple options. Here we also have batch count. This is not the same as the batch we used before. Think of this like a counter where you tell it how many times to run the workflow. So if I set the value to 4 and hit Run, it will run once, then again, and again, until it has run 4 times. This is a bit slower than the previous batch method, but it uses less VRAM. If we add these values, we get over 14 seconds. With the batch and empty latent, we got 13 seconds. You might say, 1 second is not much, but if you use bigger images and longer workflows, seconds can quickly turn into minutes. Let's change the batch back to 1, and let's explore more run options. Run on change will run the workflow when we change a value, so if I change the seed, it will start running. It should stop after the run, but I am not sure if this is a bug or if this is how it is supposed to work. Because the seed is random, it keeps generating continuously after the first change. But if the seed is fixed, it only runs the workflow when I make a change, and then it stops. So I will stop it manually by switching back to Run. If I change it to Run Instant, it will generate forever until you stop it. So do not forget to stop it by going to the arrow and selecting Run. After it finishes that workflow, it will stop. But what if we want to run multiple prompts? Until now, we only had one prompt, and the seed was different. But for the Z image model, for example, the seed variation is not that big compared to other models like Flux or Stable Diffusion. So let's search for a node called iTools Line Loader. This node loads each line as a prompt. If we drag a link from this line loader output and connect it to the text encoder, a small dot will appear in the top left corner of that text input. By default, you have 3 prompts here: cat, dog, and bunny. Let's say the first prompt is a cat photo, the second prompt is a bunny with a flower, and the third prompt is a lion logo. We have a seed here that decides which prompt will generate, and we also have control after generation. Randomize means that after each generation, the seed will change to a different random value. So let's run it. We got a cat, and now we have a different seed. For this seed, we got a bunny. Now let's change the seed to fixed, so we can understand better how this works. For the seed, we put 0. In computer programming, lists usually start with 0, not with 1. So instead of 1, 2, 3, it is 0, 1, and 2. So 0 corresponds to the cat prompt. If I run the workflow, I get a photo of a cat. If I change the seed to 1, it corresponds to the second prompt, which is the bunny, so the result is a bunny. And for seed 2, we get a lion logo. Now we know the order in which this node uses the prompts. Can you guess what we will get for seed 3? It will start over with the first prompt, so the result will be a cat photo. Let's add another prompt, like a rose, and maybe a house with a car in front. I will start with 0, so it starts with the first prompt. Then for control after generate, I will use increment, so it starts with the first prompt and continues with the next one, and so on. This way it is more controlled and not random. Now that we have 5 prompts, I can change the batch to 5, so it runs the workflow 5 times. You can see it will generate all those images, one prompt at a time, in order, and it will stop after 5 generations. You can also put 10 if you want to get 2 generations for each prompt, or you can let it run continuously and stop it when you get something you like. We saw how we can load prompts line by line, but we can also load prompts from a text file. Let's search for iTools Prompt Loader. As the name says, this node loads prompts from a file. Let's drag a link from it to the positive prompt. You can see here it says file path. We already have an example with a prompts.txt file, so let's run it. It will pick a random prompt from that file, and the result is this cat. Now let's find that prompts text file. Let's go to the ComfyUI folder, then go to Custom Nodes, and here look for the ComfyUI iTools folder. These are all the files used by that node. Basically, the node itself looks like this. If we go to the examples folder, we have a text file with prompts. Let's open it. You can see we have a few prompts here, and the image that was generated corresponds to one of these prompts. You can delete everything and add your own prompts here one by one, or you can ask ChatGPT to generate a bunch of prompts. So maybe I will add one for a dog, maybe one for a cat, and one for a rose. Now I can save that file and close it. Let's go back to ComfyUI and generate again. It should pick prompts from the same text file. Now we got that cat playing with a mouse. Let me remove this node and try again to see if we get another prompt. And now we got a rose. If the text file is in a different location, you just add the path to that file here so it knows where to load it from. And of course, you can change to run instant and let it run, then stop it when you have enough images generated. Let's delete this node and I will show you more things you can do. Let's search for a node called iTools Prompt Styler and select this one. This node picks prompts or art styles from a file. We have positive and negative prompts, but since our workflow only uses the positive prompt, we drag a link from there and connect it to the positive prompt input. Here we have an area where we can type our prompt. Let's say I type a white bunny holding a rose. Then we can select the style file. These files that contain different prompts are stored locally. Let's go to the Custom Nodes folder again, then to iTools, and this time go to Styles. You can see here a few example style files, which are actually YAML files. If we go to more examples, we have even more. Now, if we look back here at the file list, we can see exactly those files. Among them, there is one called Pixaroma. I asked the creator to add my file there so you can access it easily. Thanks, Makati. Once you have the file selected, you can choose a template from that file. You can see here different templates. For example, I can select a 3D icon or something else. What is important to remember is that you select the file first and then the template inside it. For example, let's open one of these files with Notepad so we can see what is inside. Each template looks like this. You have the template title, the negative prompt, and the positive prompt. As you saw in our workflow, we only use the positive prompt this time, so it will only pick that part. In the positive prompt, you can see the word prompt inside brackets. That is where it takes your prompt and combines it with the rest of the template prompt. So if I do not have anything selected here for the template, it will use something like landscape photography of the prompt. And instead of the word prompt, it will insert a white bunny holding a rose. Basically, we recreated what these styles do. This system saves you time by letting you write a short prompt and combine it with a ready-made prompt from a template. This was created back in the days for Stable Diffusion models, when we did not have access to AI prompt generators. It still works today with most models that recognize these prompts, even though you have much more freedom using a custom prompt made with ChatGPT. So if the prompt is a white bunny holding a rose, and for the file I select the Pixaroma file, then for the template I can filter by landscape and select photography landscape. Now when I run it, it should combine my bunny prompt with the landscape photography prompt. And the result is this one, so everything works quite nicely. Let's change the template. Let's say I select 3D icon and run the workflow, and we get this 3D icon of a bunny holding a rose. Now let's try an ancient Egyptian mural. We run it again, and we get this mural, and you can clearly see our bunny in the image. Let's say I select the Rococo art style. The result is this decorative style illustration of the bunny. Now let's open the Pixaroma styles file with Notepad. You can see all the templates and prompts for each style, and you can edit them if you want. Just keep the same format, otherwise it will not work. Let's say I want to use the template for Surreal Toy. If I use it in the workflow, it will take this prompt and replace the word prompt with my bunny holding a rose. So let's test it. From the templates, I search for Surreal and select that toy style. Now let's run the workflow, and we get this 3D surreal bunny with a rose. Pretty cool. Let's scroll down and see what else we can use. Let's say Afrofuturism art. That means it will use that specific prompt. Let's change the style and test it. And the result is this one. Keep in mind, each model will interpret these prompts differently depending on how it was trained. There are over 300 styles or prompts saved in this file, from 3D to art styles, painting, photography, design, all kinds that I use most often. Let's say I select the vector coloring book page style. Now when I run it, I get this clean coloring page design. Of course, if you want it to be more unique, give more information in the prompt, like how the bunny looks, how it is dressed, how the environment looks, and maybe make it fit your story. Let's say I want to do a cartoon illustration. Let's search the list to see if we have something like that. For example, I can select a soft 3D cartoon environment and see what we get, and the result is this one. Let's search for cute and test this cute cyberpunk style, and we get this illustration. These are good for discovering art styles you might not have thought to try yet. Now let's remove this node and search again. This time we look for iTools Prompt Styler Extra. It is called Extra because it has slots for multiple files and templates. Let's connect it to the positive prompt. For the base file, let's select the Pixaroma file, since that one has the most styles. For the second file, I will use the same one. Let's set both to random, so we get a random combination of two styles. If I run it now, I get something like this. There is no bunny because we added a new node and we did not add a prompt yet. Let's drag a link from the output called Used Templates. This outputs the actual styles that were used. Then search for Preview and add a Preview as text node. Now when I run it, you can see what styles it combined. Reflection with fantasy. Now let's add the prompt, a white bunny holding a rose, and generate again. This time it combined propaganda art style with knitting art. something you probably would not think to combine. Let's select a third file, again the Pixaroma file. For the third style, let's select Random, or any other style you want. Now, if we look again, it combined Japanese, traditional, sticker, and fine art. Let's run it once more, and we get this gilded fantasy bunny. Pretty cool. Let's try again, and this time we get a cute, minimal line art style. Of course, you can also manually select which styles to combine. For example, let's choose a game asset style combined with low poly, and for the third one, select Atom Punk, and the result is this one. You can also run it multiple times to get different seeds. By now, you should start to get an idea of how styles work. Let's try one last combination. Change low poly to a steampunk style. We get this image because we used a game asset style. If I change the game asset to cute cartoon, I get this cute bunny in a steampunk environment. So create your own styles for the things you use most often, or use ChatGPT or other large language models to generate longer prompts that describe exactly what you need. In the previous chapter, we saw how we can use different prompts to change the style of the image, but if we want a style that the model did not learn, we cannot generate that style. For that, we have the LoRA files, which add extra information to the main model. We talked more about this in episode 13. Let's go to Workflows, and this time let's select workflow number 6, the one with LoRA in the name. This is a simple Z-image text-to-image workflow. In fact, if we remove these nodes, we get exactly workflow 5A that we used before. So let's undo that. What is different here is this LoRA Loader model-only node, which allows us to load a LoRA from our computer. I just changed the color to blue, that is all. The node with trigger words is just a simple note. Again, revisit chapter 13 for more details. So let's go and download a LoRA. I created a LoRA for a girl with white hair, and you can download it from here. After that, navigate to Comfy UI, go to Models, and then open the LoRAs folder. Here we already have one from chapter 13, the SD 1.5 LoRA. Now we create a new folder called Z-image, since this LoRA only works with the Z-image model, and we save the LoRA inside that folder. After the LoRA is downloaded, press the R key to refresh the node definitions. Now if we go to the LoRA Loader, we can select that LoRA. You can see the folder and the LoRA name there, just like for all other LoRAs. This is the trigger word that I used when I trained that LoRA. I use that in the prompt, together with more words to describe what I want to generate. Now when I generate, I get this girl with white hair. The LoRA I am using here is a character LoRA. There are also LoRAs for styles, objects, or functional ones that speed things up. This also allows you to keep a character consistent, so even if you change the prompt and keep the trigger words, you get the same character, which is very useful. There are many LoRAs trained by people online, on sites like Hugging Face or Civit AI. Over time, you can also learn how to train them yourself, either online or locally, if you have enough VRAM. Let's search for a LoRA on the Civit AI website. Again, if you are from the UK, you will need a VPN to bypass the restrictions they set for your country. Let's go to Models, then we can filter them. Set time period to all. For model type, select LoRA. For base model, select Z-image Turbo. Now we should see only LoRAs compatible with our base model. We can sort by highest rated. We have quite a few here. Let's pick one at random, maybe this one that lets us create character design sheets. Now we are on the LoRA page. At the top you can see this LoRA is available for different models, but we want the Z-image version. We check the type to make sure it is a LoRA and that the base model is correct. We also check if it has trigger words or other settings. Then we can download it from here. You must be logged in to download models. We save the LoRA in the same LoRAs folder inside the Z-image folder. After the download finishes, press the R key to refresh. Now we should be able to see that LoRA in the list and select it. Let's see what else it says about this LoRA so we can learn more. Here it shows the trigger words. I can copy those and paste them in a note so I have them for later. They also give an example prompt showing how to use it. Let's copy that and paste it into the positive prompt. I will remove the beginning and ending quotes. Now let's copy the trigger words and place them here instead of the previous trigger words. We also have a subject, so let's say a white bunny warrior. For art style, maybe I add a 3D render style. The rest looks fine. For the model strength, I will use 1. If it is too strong, I can reduce the weight. For the size, let's make it bigger so we get more details. Now let's run the workflow. We get this character sheet, which is not bad. This could be useful for concept artists to see different angles. Let's run it again with a different seed, and we get this result. Now let's change some things in the prompt. Maybe it is a medieval bunny. For art style, I try a vector art style. Let's run the workflow again. Now we get a different image. This seed does not look that good, so maybe I try another seed to see if I get something better. Again, not perfect, but at least it gives some ideas. Let's go back to Civit AI and look again at models. You can see there are LoRa's for all kinds of things. That does not mean all of them are great. They are trained by people like you and me and shared for free. Depending on the training, some are very good and some are not so good. Training is never perfect. If you want to see how much the LoRa influences the result, we can test that too. Change the seed to fixed and generate once to see the result. In my case, I got this image. Now let's go to the LoRa Loader node. Right-click on it and select Bypass. Then we run the workflow again with the same settings and prompt. You can see that without the LoRa, we do not get a character sheet anymore. So this LoRa clearly helps with creating multiple characters on a sheet. Remember, a LoRa is like an add-on to the main model. It adds extra training to that model, like the model took a new course and learned how to do character sheets. Hope that helps.